Hello everyone. The topic of today's lecture is cash flow. The learning objectives for this session are to grasp the concept and significance of cash flow, as well as how to draw and calculate a cash flow diagram. Alright, let's start by drawing a cash flow diagram. First, we need to understand what cash flow is. Let's take a look at the concept and components of cash flow. Cash flow, as the name suggests, refers to the inflow or outflow of cash, just like water flowing. For example, during Double 11 shopping festival, many women find their bank balances gradually decreasing, with cash flowing out like water. Cash flow is the primary analysis object in the financial feasibility analysis of investment projects. Financial evaluation indicators, such as net present value (NPV), internal rate of return (IRR), and payback period, are all based on cash flow. For feasibility assessments, profit is merely the outcome of a financial report over a certain period. And for the financial feasibility of an investment plan, the cash flow status of the project is more important than the profit or loss during the accounting period. Whether an investment project can proceed smoothly and whether it is economically beneficial does not necessarily depend on whether it generates profit during the accounting period, but rather on whether it can bring in positive cash flow. That is, whether the project can recover more cash than the initial investment. The actual outflow or inflow of funds at each time point, t, during the entire observation period of an engineering project, is collectively referred to as the project's cash flow. When understanding the concept of cash flow, we need to focus on two aspects. One is the perspective, which involves analyzing the difference between cash inflow and cash outflow from the standpoint of a specific technical plan. The other is the category, which divides cash flow into three types: cash inflow, cash outflow, and net cash flow. First, cash inflow refers to the funds flowing into an engineering project, denoted by the symbol CIT. It typically originates from operating, sales, revenue, residual value income from the scrapping of fixed assets, and the recovery of working capital at the end of the project. Second, cash outflow refers to the funds flowing out of an engineering project, denoted by the symbol COT. It usually covers payments for the enterprise's invested capital, construction investment and working capital investment, taxes and surcharges, operating costs, and other expenses. Third, net cash flow refers to the difference between cash inflow and cash outflow, denoted by the symbol C-CO multiplied T. It's important to note that the subtraction can only be made if the cash inflow and outflow occur at the same time point. To illustrate the above 2 points, let me give you a simple example, and you can get it. Let's say you get paid by your company on the 15th of every month, and you receive a salary of 10,000 yuan. You're in a great mood, and give 9,800 yuan to your spouse when you get home that night, telling them that it's your entire month's salary handed over to the family without reservation. Now, let's analyze the example. The first question is, for these 10,000 yuan and 9,800 yuan, cash inflow and cash outflow need to be viewed from a specific entity. From your perspective, the 10,000 yuan is cash inflow, and the 9,800 yuan is cash outflow. However, if you change your perspective, it may not be the same. For the company, the 10,000 yuan is cash outflow, And for your spouse, the 9,800 yuan is cash inflow. Therefore, when evaluating a plan, you must determine the perspective from which to judge cash inflow and cash outflow. Both amounts occurred on the same day, so the net cash flow here is 10,000 to 9,800, leaving you with an extra 200 yuan in your personal savings. Note that cash flow can be positive or negative. Positive cash flow indicates net income at a certain time point, while negative cash flow indicates net expenditure at a certain time point. Cash inflow and cash outflow are collectively referred to as cash flow. The purpose of engineering economic analysis is to analyze the cash flow situation of the economic system being examined, based on its expected goals and available resource conditions, and to select the appropriate engineering and technical plan to achieve the best economic results. Cash flow is generally measured in interest-bearing periods, such as years, quarters, months, etc., and can be represented using a cash flow diagram or cash flow statement. Let's now take a closer look at section 2.1.2, which discusses cash flow diagrams. Cash flow diagrams are crucial because for a technical plan, the direction, expenditure, or income, amount, and timing of each cash flow may vary. To correctly perform engineering economic analysis and calculations, it is necessary to use a cash flow diagram. For analysis, a cash flow diagram is a graphical representation that reflects the financial movement status of a technical plan. It plots the cash flows of the technical plan onto a timeline, showing the correspondence between each cash inflow, outflow, and the corresponding time. By using a cash flow diagram, we can comprehensively, vividly, and intuitively express the financial movement status of the technical plan. A cash flow diagram includes three essential elements: magnitude, direction, and time point. The magnitude represents the amount of funds. The direction indicates whether it is a cash inflow or outflow for the project. And the time point indicates when the cash inflow or outflow occurs. Now, let's use as an example to illustrate the method and rules for drawing a cash flow diagram. 1. The horizontal axis is known as the time axis, representing a time series starting from 0. Each tick mark on the axis represents an interest-bearing period. For example, if interest is calculated annually, the tick marks on the time axis are in units of years. On the time axis, 0 represents the starting point of the time series, indicating the start of investment or the evaluation time point. And the numbers from 1 to n represent the endpoints of each interest-bearing period, or the end of the project. Except for 0 and n, each number has two meanings. For example, 3 represents both the end of the third interest-bearing period and the beginning of the fourth interest-bearing period. 2. The vertical arrows on the time coordinate represent cash flows at different time points. Arrows above the horizontal axis indicate cash inflows, that is, benefits. Arrows below the horizontal axis indicate cash outflows, that is, expenses or losses. The length of the arrow is proportional to the amount of inflow or outflow. The larger the amount, the longer the corresponding arrow. The length of the arrows should appropriately reflect the differences in cash flow values at various time points, and the numerical value of each cash flow should be indicated above or below the arrow. Third, the direction of cash flow, inflow or outflow. is relative to a specific entity. An inflow for the lender is an outflow for the borrower, and vice versa. Typically, the direction of cash flow in a project is considered from the perspective of the fund user's system. Fourth, the intersection of the arrow and the time axis indicates the time point when the cash flow occurs. From the above content, we can see that a cash flow diagram includes three essential elements: magnitude, the amount of cash flow; direction, cash inflow or outflow; and time point, the time when the cash inflow or outflow occurs. Next, let's take a look at Section 2.1.3, which discusses the cash flow statement. A cash flow statement, Table 2-1, is a table that directly and clearly reflects the cash flow, fund revenue and expenditure situation of a project for each year within the entire calculation period. It can be used for cash flow analysis and to calculate various static and dynamic evaluation indicators, serving as the main basis for evaluating the economic effectiveness of project investment proposals, as can be seen from Table 3-1. The vertical columns of the cash flow statement represent the items of cash flow, arranged in the order of cash inflow, cash outflow, and net cash flow. The horizontal rows of the table represent the year sequence, arranged according to the various stages of the project calculation period. The entire cash flow statement encompasses the development and changes of various cash flow items, making it intuitive, convenient, and highly comprehensive, based on the net cash flow. In the cash flow statement, we can directly calculate major economic evaluation indicators, such as net present value, static payback period, and dynamic payback period, which are very intuitive and clear. The cash flow statement is a commonly used analysis tool in practical operations. That's all for this video. Thank you, everyone.